Point slope.
Alright, point slope is easy. Okay.
I don't like
Okay, so we're talking about polygons and the coordinate plane. We've learned several different formulas throughout the year, and so now we're going to apply, when and how to use these things. Okay? So if you looked at the first, it says, what formulas can you use to identify properties of the figure in a coordinate plane? What formula would you use to find AB? Now, what somebody else said. Distance, right? Because distance tells you how long something is, right? Okay, it tells you the length. Okay? So we would use the distance. Okay? And remember, your distance formula is the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So if I wanted to find the length of AB, and it doesn't matter which one's x1, which one's x2, as long as you're consistent, okay, with what you do. All right, so we're going to do, let's see, AB, so that would be 1 minus 3 quantity squared plus, subtract your y, 6 minus 1 quantity squared. That ends up being negative 2 squared plus 5 squared. Negative 2 squared is a positive 4 plus 5 squared, which is 25. That would be graph 9. Okay, so the length of AB is radical 29. We use the distance formula to figure that out. Okay, what point bisects AB? What would you use? Because it's asking you what formula you would use. The midpoint, right? Midpoint tells you a location. It's a point. It's an ordered pair. It's equidistant to the two midpoints. All right? So, for midpoint, it's like averaging the endpoints. So it's x1 plus x2 divided by 2, and y1 plus y2 divided by 2. And that gives you an x midpoint and a y midpoint. Okay? So, if we're going to find the midpoint of AB, we would add our x's together. So that would be 1 plus 3 divided by 2. And then 6 plus 1 divided by 2. 1 plus 3 is 4. Divided by 2 is 2. 6 plus 1 is 7. Divided by 2 is 3.5. Okay? So if I look here, I'm at the 2 and then up. 1, 2, 3 and a half. That's my midpoint. Okay? And that location is 2, 3.5. Okay, so the midpoint gives you a location, an ordered pair. It's a point that's equidistant from the two endpoints. Okay, what do the slopes of AB and BC show that measure ABC equals 90? What do we use slope for? Just in general, what do we use slope for? What does it tell you? Not the height, that's the length. It could indicate a certain measure. It shows you the steepness of a line. Okay, like in a graph, it shows you the steepness of a line. A trend sometimes is called a trend. Okay, and so if I looked at AB and BC, what's going to happen with the slope in order to show that that angle created by them is 90 degrees? If they were the same, they would be parallel, right? Because they'd have the same steepness, right? But what's going to make them be perpendicular?
It's like
Well, let's look at it. Opposite something. Opposite reciprocals. Yes, opposite reciprocals. All right. So let's look. Remember that the slope is y2 minus y1 over x2 minus x1. And it could be in the opposite order as far as y1 minus y2. You just basically subtract the y's, subtract the x's, the y's go on top. You have to make sure you subtract them both in the same order though. Okay, so for the slope of AB, you would do 6 minus 1 and 1 minus 3. That gives me 5 over negative 2. And then if I look at the slope of BC, that would be 1 minus 3 over 3 minus 8. And so that's negative 2 over negative 5, which is a positive 2/5. So see how they're opposite signs. One's negative, one's positive, and they're reciprocals of each other, right? What would happen if I multiplied those two together? Use your calculator. Good, great. 5 times a negative 2 over 2 over 5. I mean, 5 over a negative 2 times 2 over 5. What is that equal to? Negative 1. Anytime their opposite reciprocals, their product is negative 1. Okay? So, when you have two lines whose product is negative 1, or their opposite reciprocals, that tells you that the lines are perpendicular, that they form a right angle. Okay? If they were the same slope, it would tell you that they were parallel. Okay, so we're going to be using distance, midpoint, slope. Okay? Alright. Is triangle XYZ equilateral, isosceles, or scalene? Well, we can't just look at it and tell. What are we going to have to do? Slope tells us the steepness.
Distance between y and
Because equilateral, they'd be the same length. Isosceles, you'd have two sides that were the same. And scalene, they'd all three be different, right? So we're going to have to use the distance formula and look at the length of all three sides. Okay? All right. So we're going to start out with xy. All right. So let's see. We're going to do 5 minus 1 quantity squared plus 8 minus 2 quantity squared. That's going to give me 4 squared plus 6 squared equals 16 plus 36, which is square root of 52. Okay. Then we want to look at xz. And so that would be 1 minus 8 quantity squared plus 2 minus 6 quantity squared. So that would be negative 7 squared plus negative 4 squared, which is 49 plus 16, and that's 65. Okay. Now, if my picture was graphed for me already, would I need to do the third side? No, but if I didn't graph it, would I need to do the third side? Yes, if it wasn't graphed, I would need to do the third side. So I'd have to look at YZ, and that would be 5 minus 8 quantity squared plus 8 minus 6 quantity squared. So that would be negative 3 squared plus 2 squared, which is 9 plus 4, which is radical 13. So what does that tell me about the triangle? Okay, it tells me that it's scalene. All three sides have a different length. Okay, now I want to know, is this a right triangle? So what am I going to have to look at? I'm going to have to look at slope. Okay? So, let's see. Slope of xy. Let's see. I would subtract the y's, put them on top. So 8 minus 2 over 5 minus 1. Sometimes you really have to think when you go to do this. Do I add or subtract? What's the formula? You may want to write it down. Okay? So that you don't get them mixed up. Because they're easy to get mixed up when you're interchanging them. So you get 8 minus 2, which is 6. 5 minus 1, which is 4, and that is 3 over 2. Then we would look at the slope of YZ. That would be 8 minus 6 over 5 minus 8, which is 2 over a negative 3. What does that tell me? Their product is negative 1, which means they are perpendicular. So XY is perpendicular to YZ. And so what kind of triangle? And so that makes it a right triangle. XYZ. There would be no reason really for me to look at the slope of the third one because you can only have one right angle, right? So my right angle is right here. Now, if it was graphed, could I count the slope? Yeah, I could. I could have gone, start here, rise, 1, 2, 3, 4, 5, 6, run back, 1, 2, 3, 4. So that's 6 over negative 4, which is a negative 3 halves. And here I would rise, rise, 1, 2, back, 1, 2, 3. X, Y, 1, 2, no, positive. 6 over 4, which is a positive 3 halves, and then this one is a negative 2 thirds. So, you could have counted if it was graphed. If not, then you would have to rely on it. And me, formula isn't even better than me counting, evidently. Okay. Now, you're going to be asked to determine what kind of parallelograms these are. Now, what's true about a parallelogram? What do we know about parallelograms? Opposite angles are congruent. Opposite sides are parallel. What's true about the diagonals? They're not perpendicular and they're not square.
They bisect each other.
They bisect each other, which means they have the same midth, right? So if two things bisect each other, they have the same midth. So keep that in mind, okay? Now, if we know it's a parallelogram, then you can determine if it's more easily. You can determine if it's a rectangle, a rhombus, or a square. Okay. If it's a rectangle, you know that the adjacent sides are perpendicular, right? Which means that the slope of one side and the slope of the other are going to be opposite reciprocals, right? Because these obviously are going to be the same slope, and these are going to be the same slope. But if the adjacent ones have slopes that are opposite reciprocals, that tells you that there's a right angle. That means that it's going to be a rectangle, okay? If you already knew it was a parallelogram, you would just need to check one pair of adjacent sides because you already know that your opposite ones are parallel, okay? Also, if you know that it's a parallelogram, what else is true about a rectangle? Well, if it's a parallelogram, opposite sides are congruent. The diagonals are congruent, right? So if you know ahead of time that it's a parallelogram, you can check the length of the diagonals. But if you didn't know that it was a parallelogram, you wouldn't want to use that test because what other shape has congruent diagonals? Well, a square, obviously, but a square is a rectangle. An isosceles trapezoid has congruent diagonals. And is a trapezoid a parallelogram? No. Well, okay, think about it. You're just hollering stuff out. Think about it. Is a trapezoid a parallelogram? No, what does a parallelogram have to have? Opposite sides parallel. A trapezoid has one side parallel and the other ones aren't, right? Okay? So, but the isosceles trapezoid and the rectangle have congruent diagonals, right? So, you could only use that test if you knew ahead of time it was a parallelogram. Okay, your rhombus is a parallelogram, so it has all those properties. All the sides are congruent, right? So you could look at the length of the sides. If you knew it was a parallelogram, you would just have to look at a pair of adjacent because you already know that opposite sides are equal. And then to be a square, it has to be what? A rhombus and a rectangle. Okay? So you have to use a test from and show both of those apply. And if both of those apply, then you can say that it's a square. Okay? All right. So we want to first of all see if it is a rectangle. Okay? Alright, so do we want to look at the slopes of the sides, or do we want to look at the length of the diagonals? Slopes of the sides? Okay. So we'll use, how about SR and ST? Okay, so we'll look at the slope of SR and we'll look at the slope of ST. Okay, so we'll look at the slope of SR, that would be difference in the Y's or the difference in the X's. So that's 3 over 1, which is 3 over 1, yeah, which is 3. ST, you would do the difference in the Y's, 8 minus 4 over 2 minus 8, and that's going to be 4 over negative 6, which is a negative 2/3. So, is this a rectangle? Why not? They're not opposite reciprocals, right? Okay, they're not opposite reciprocals. So, this is not a rectangle. So now we want to look to determine if it's a rhombus. Okay, what should we look at to determine if it's a rhombus? Look at the side lengths. We'd have to do all 4? No, since we already know it's a parallelogram, I could look at a pair of adjacent ones, right? So again, let's look at SR and ST. Okay, so if I looked at SR, let's see, we're going to use distance this time. And so that would be 2 minus 1 quantity squared plus 8 minus 5 quantity squared. That would be 1 squared plus 3 squared, which is 1 plus 9, which is radical 10. So this right here is radical 10. Okay, then we're going to look at ST, and that would be what? 2 minus 8 quantity squared plus 8 minus 4. That would be what? Negative 6 squared plus 4 squared, 36 plus 16, and that's what? Radical 52? So this is radical 52. So is it a rhombus? No. Okay. So it is not a rhombus. It's not a square. What is it? It's a parallelogram. Okay, it is a parallelogram. That's it. Nothing else special about it, right? All that work. Well, it wasn't for nothing. It eliminated a bunch of things, right? Okay. What do you think when you're a private investigator or a detective? How many times does all your hard work show you that that's not the right answer or the right person or the right motive? Not all the time. Okay. Now, what, Toady, are we going to have to do to determine if this is a trapezoid? What has to be true in order for it to be a trapezoid? 2 pairs or just 1 pair? 2 that are one pair, right? So can I just hopefully find the 2 that are parallel, or do I have to look at both pairs? I have to look at both pairs. Because I'd have to show that 1 pair was parallel, and I'd have to show that the other pair was not. Because if the other pair ended up being parallel, it would be a parallelogram of some sort. Could be a rectangle. Yeah. Alright. So, let us look at our slopes. So we will start with the slope of AB. Okay. And so that would be 5 minus 3 over 1 minus 4, which is 2 over negative 3. And then we'll look at its opposite side, slope of CD. Okay, and so that would be what? 8 minus 4 over 7 minus 6. And that's 4 over 1, which is 4. So those are not parallel. That's good, right? Okay, so AB is not parallel to CD, right? Okay, so now let's look at the slope of BC. Okay, and that would be 8 minus 5 over 7 minus 1,
3 over 6, which is 1/2. And then the slope of AB, which would be 4 minus 3, excuse me, over 6 minus 4, which is 1/2. Okay, so that tells me that BC is parallel to AB. So that tells me that ABCD is a trapezoid. Okay? And this is justifying it. No, that wouldn't be justifying. Now, if it was graph, I could have counted the slopes. Yes. But that would not be justifying. Because what if your graph was off? I've seen the way you draw lines. It happened. Alright. Now, what if I wanted to determine if this was a kite? Alright. 2 pairs of consecutive sides, right, are congruent. Okay. So we get to use everybody's favorite formula, right? We've got to show that we've got 2 pairs of consecutive sides that are congruent. Alright, so we'll just work our way around. KL. Alright, so let's see. We'll do 1 minus 0 squared plus 8 minus 5 squared. That gives me 1 squared plus 3 squared equals Raphel-10. Right? So this right here is Raphel-10. Then we're going to look at LM. Okay, so we look at LM. We'll do 4 minus 1 squared plus 7 minus 8 squared. That gives me 3 squared plus negative 1 squared. That's Raphel-10, right? Okay, so we've got 2 pairs of adjacent sides through it. Now let's see if the other 2 match up. Okay, so then we're going to do MJ. And let's see, what can we do with MJ? Look at it. I'm not going to do extra work. What can I do with that? What kind of line is that? Oh, it's a straight line and it's graph. What can I do? Count it. 1, 2, 3, 4, 5. Okay, so NJ is 5. Okay, then we want to do KJ. Let's see, 4 minus 0 squared plus 2 minus 5 squared. That gives me 4 squared plus negative 3 squared, which is 16 plus 9, which is radical 25, which is 5. Right. So, is it a kite?
Yes.
Yes. We got 2 consecutive pairs of sides congruent. 2, yes, consecutive. 2 consecutive pairs of sides congruent. All right. Last one here. It's got 2 parts. Okay. Dylan draws up a plan to fence in a yard for his chicken. The distance between the grid lines is a foot. Is 30 feet of fencing enough to enclose the yard? Okay. That's very geometrical. Okay, so BC is easy, right? It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're good. Okay, now let's look at AB. Alright, so AB we would do 10 minus 2 squared plus 12 minus 6 squared. See, the more you do it, the quicker you get. So you get 8 squared plus 6 squared, 64 plus 36, which is 100, which is 10. Let's see. AC. That was my thought at first too, but I think I proved my conjecture wrong. Alright, so now we're going to do 10 minus 2 quantity squared plus 2 minus 6 quantity squared. That gives me 8 squared plus negative 4 squared, which is 64 plus 16, which is 80. Square root of 80 is going to be almost what? Almost 9, right? The square root of 81 is 9. So this is going to be 8.9 approximately, right? Okay, so is 30 feet of fencing going to be enough? Okay, last one. For a healthy flock, each chicken needs at least 8 square feet of space. What is the maximum number of chickens Dylan can put in the yard? So now we've got to find the area. Okay? It's pretty easy. Think about it. It's not isosceles. It's not isosceles. Oh, yeah, it is. I'm sorry.
Bro,
Wait.
you're really good.
Wait, you have a 30-second offer.
No. It is isosceles. You're right. Okay, I guess what I was thinking is you're overlooking the obvious. It is isosceles. You're 100% right. Yes. Huh? And you could go with that, but it would be a whole lot more work. Look at the graph of it. I have a base that is vertical. My height, if my base is vertical, my height needs to be horizontal. And it has to come from a vertex.
It's 2, 6 to 10. 6.
Right. Could I just draw this right here for my height? Yeah, because I'm coming from a vertex. If it's horizontal, vertical, that's horizontal, right? So I wouldn't have to do too much work. Okay? So,
Wait, plus 2, 6.
huh?
Blue square. Oh, boo.
Okay, alright, so we have a base and a height, right? Alright, so for the area of the triangle, it's base times height divided by 2. What's the length of the base? We said it was 10. The height is 1, 2, 3, 4, 5, 6, 7, 8. Divided by 2, and that gives me...
40 chickens.
No, it is 40 chickens.
They don't need They don't need square feet.
It's not 40 chicken equals 5.
But how did you think
Hey.
it's 5?
Okay,
I didn't guess.
it's 40 square feet, right? Now, each chicken needs at least 8 square feet, right? So we would divide that by 8, which means we could have 5 chickens.
8 you don't need 8 square feet. Yes, chicken.
Okay. All right.
That's a very tiny pen, then, I guess.
So, we learned how to utilize 3 things that we already knew, right? We already knew about distance, midpoint, and slope. We can use the distance formula that lets us know, as far as length is concerned, lots of different things. Remember, the distance formula tells you the length of something. The slope formula tells you the steepness. That will help us determine if things are parallel or perpendicular. If they're perpendicular, their slopes are opposite reciprocals. Their product is -1. Okay, that tells you whether there's a right angle right there. Okay, and then midpoint, it gives you a location. Okay, it's an ordered pair that's equidistant to the 2 points that you found the midpoint between.